I've been doing a series recently on the evolution of stars, on stars with different spectral types and living along the main sequence and then evolving off and becoming giant stars. But I want to take a moment to talk about the before picture of how stars actually get started. Stars come from nebula. Stars are born from nebulae. And not just any nebula can produce a star. It has to be something called a giant molecular cloud. A giant molecular cloud is a nebula, but it's a special kind of nebula because it's relatively cool. If the gas in a nebula is too hot and too energized, then it won't be able to contract. It'll just keep floating around and waving around. In order to make a star, you want to pull that material in. You want it to collapse. You want it to scrunch down. And in order to do that, you need to make it cold. So giant molecular clouds are cold. I mean, colder than average. They're cold enough where clumps of them, parts of the nebula, can start contracting and squeezing down to form stars or a star-forming region. A typical giant molecular cloud, once it gets into the star-forming game, can produce, a few dozen to a few hundred stars, depending on its mass. There are smaller versions of giant molecular clouds known as Bach globules. And no, I did not make up that name on the spot. These are just small, dense clumps that can only pop out a few stars. And then we see them every once in a while. But giant molecular clouds are the real star-forming factories of our galaxy. Once they get unstable, they can start compressing down and forming stars. Once the first stars form, they will spew out a lot of radiation. They'll have solar winds, and they'll typically wipe away the rest of the nebula and leave behind the stars. We see this in the pillars of creation in the Eagle Nebula, that famous NASA photo that has these huge pillars of gas. What's happening is that there are newly formed stars that are carving channels down into the gas, eroding away the sand around some dense clumps. Once stars start forming, they compress down, they'll form an accretion disk. They'll also form jets because there's a lot of magnetic field action happening there that can swirl the material around and form little jets, exactly like what we see around, say, binary X-rays, what we see around active galactic nuclei, but way weaker and way lower scale. When small mass stars form, no bigger than 2 times the mass of the sun, in this protostar stage, they're called T Tauri stars, named after the first object that we identified that looks like this. And if it's a much more massive star at this stage, at its embryonic stage, it's called a Herbig AE star or AEB star. Either way, what you get is a disk of material, the collapse of a protostar, which is very, very, very hot, but not quite igniting nuclear fusion, and then usually some jet action and some clearing of a cavity around it. Then once nuclear fusion ignites, which takes a few million Kelvin to get going, once that ignites, it's not a protostar anymore. It is a true and proper star. If it has a binary companion, it's formed by now. If it has a family of planets, the planets have formed by now. And then that is when the star enters the main sequence. That is when it begins the hydrogen burning phase of its life. And as it lives, it will travel along the main sequence, slowly getting hotter and brighter as time goes on. Then when it's done burning hydrogen, it exits the main sequence and explores the land of the giants. It can come up with all sorts of different colors and sizes and luminosities as it's going through its death throes. And then what it leaves behind will occupy another corner of this Hertzsprung-Russell diagram where the white dwarfs live. So most stars are going to leave behind a white dwarf, which is just a compact lump of carbon and oxygen, no big deal. And the biggest stars will go out with a supernova and leave behind a neutron star or a black hole. All of those are called stellar remnants. All of those are the leftovers, and all of those are not true stars. Even though neutron stars and white dwarfs are sometimes called stars, what we really mean by star is something that is capable of nuclear fusion. And 90% of the time, that refers to a main sequence star, something that is living on the main sequence. So I hope you found this informative. If you did or didn't, either way, please contribute to patreon.com/pmsutter. There's a link down in my bio or in the little show notes down there. Like, share, subscribe, check out another video. I'll see you next week.